Hello everyone. So, let us discuss your question paper and this discussion is for physics. So, let us start with question number 1, which is question number 101 in your paper. So, we have two columns and we need to match column 1 with column 2. So, isotropic solids is first option in column 1. So, isotropic solids are those solids in which property is direction independent and expansion is directional property, right. Because isotropic solid is there, that means equal expansion will be there in all direction. I hope this is clear. So, for A we have correct answer as option F. Ice contracts on melting. So, B for G. Anisotropic solids are those solids in which the properties are direction dependent, right. So, it will have unequal expansion in different direction, and copper is a solid and on heating it will expand because of the thermal expansion property, right. So, correct answer for D is E. So, correct answer for this is option 2, A2F, B2G, C2H and D2A. To match 1 with 2, barometer is based on Boyle's law. Specific gas constant has unit joule per kilogram per Kelvin. Gas thermometer is based on Charles law and universal gas constant has unit joule per mole per Kelvin, right. So, correct answer is option 2. Next is 103. A cylindrical metal rod of length L0 is shaped into a ring with a small gap as shown in the figure. On heating the system, so on heating thermal expansion will be there. So, X, R and D all will increase, which is option 3. Okay. Next is 104. The kinetic energy of a given sample of an ideal gas depends only on its kinetic energy is given by 3/2 kBT. So, it depends on temperature, which is option 4. Next is 105. The numerical value of coefficient of linear expansion is independent of units of. So, coefficient of linear expansion has unit degree, Celsius inverse or Kelvin inverse. So, you can see that it is independent of length, it is dependent on temperature, it depends on area and it depends on mass, right. So, it is independent of A, C and D, which is option 4. Next is 106. In the equation PV is equals to constant, the numerical value of constant depends upon. So, we have PV is equals to nRT equation and this nRT is constant. So, this constant depends on temperature, this constant depends on mass of the gas because N over here is moles. It also depends on system of units used and it also depends on the nature of the gas, right. So, you can see that correct answer is option 4, which is all of this. Next is 107. The gas constant of a molecule, terms have usual meaning, is K or R by N, R upon Nt or R upon N. So, gas constant of a molecule is K as well as R upon N because R is equals to Na Kb, right. So, we have both A and B, which is option 3. Next is 108. A particle moves along the x axis with its position x given as a function of time t by the equation x is equals to minus bt plus ct square, where b and c are positive constants. At what time the velocity of the particle will be equal in magnitude and opposite to in direction to its initial velocity. So, we have x as minus bt plus ct square. So, on differentiating x you will get velocity which is minus b plus 2ct. On differentiating velocity you will get acceleration, right. So, we need to find the time at which the velocity will be opposite to the initial velocity. So, put t is equals to 0 in this equation, you will get v0, that is velocity at t is equals to 0 will be minus b. Now, we need time at which the velocity will be in reverse direction of v naught. So, if it is minus b initially, it will be plus b at that time. So, velocity is plus b at that time, which is minus b plus 2ct. So, you can see that 2b is equals to 2ct. So, t will be b by c, which is option 3. Let us move on to the next one. 109, a particle moves along the x axis with uniform acceleration a. It starts from rest from the origin. During its motion, the rate of change of velocity with position dv by dx is. So, we know that a is equals to v dv by dx. So, dv by dx will be a upon v. Now, particle is moving with uniform acceleration, that means with time its velocity will increase. So, if a upon v is dv by dx and v is in denominator and it is increasing with time, that means overall quantity will decrease, right. So, dv by dx will continuously decrease, which is option 2. Next is 1010. A particle is moving along a straight line. For this motion, you are given two statements A and B. Carefully examine them and select the correct option. Statement A, the velocity of the particle is always in the direction of its displacement. So, velocity of the particle is always in the direction of its displacement. That is true because v vector is equals to dx vector divided by dt vector, right. So, velocity is always in the direction of displacement. So, first one is true. Let us talk about the statement B. The acceleration of the particle is always in the direction of its velocity. No, it is not true. In the case of retarding motion, acceleration and velocity both are in the opposite direction, right. So, this statement is false. So, statement A is true, but B is false, which is option 2. Let us move on to 111. A juggler throws balls vertically up in the air. He throws one up whenever the previous one is at its highest point. Okay. If he throws n balls each second, the height to which each ball rises above the point of throw will be, where g is acceleration due to gravity. So, it is given that juggler throws n balls in 1 second. So, what is the duration between two balls? If he is throwing n balls 1 second, that means the time duration between two balls is 1 upon n second. Now, he throws second ball when first one is in air, that means at its highest point. Okay. So, when first one is at highest point, he will throw second one. When second one is at its highest point, he will throw the third ball and so on, right. Now, since the time between two consecutive throw is 1 upon n second, that means the time taken by the first ball to reach the highest point is 1 upon n second, right. So, you can see that initial velocity of the first is, let us say u, but final velocity is 0 because at highest point it will be 0. First ball will come back in the hand of the juggler in the same time, 1 upon n second, because time of ascent is equals to time of descent. For the first ball, for the downward journey, initial velocity is 0. So, you can see that h is equals to ut plus half g t square, but ut will be 0 because u is 0. So, h will be half g t square is 1 upon n whole square, which is g upon 2 n square. So, this is the height achieved by the balls, which is option 1. Next is 112. The equation under root x is equals to t plus 3 gives the variation of displacement x with time t for a particle moving along the x axis. Which of the following is correct for the motion of the particle, right. So, we have under root x is equals to t plus 3. So, on squaring both the sides, you will get x is equals to t plus 3 whole square. Now, differentiate this equation, you will get velocity, which is 2 times t plus 3, and on differentiating velocity you will get acceleration which is 2, right. Now you can see that acceleration of the particle is constant, which is option 4. Okay. Now let us move on to 113. Two particles A and B are on the x axis at distances of 4 and 16 meter from the origin. The distance of A from the origin is increasing at a steady rate of 2 meter per second, while that of B is decreasing at a steady rate of 1 meter per second. During their subsequent motion, the distance between A and B. So, we have A at plus 4 and B at 16 meter from the origin. This is your origin. Now, A is moving away from the origin because its distance from origin is increasing at the rate of 2 meter per second, while distance of B from the origin is decreasing at the rate of 1 meter per second. That means you can see that both A and B are approaching each other. So, what will be their velocity of approach? It will be VA plus VB because both are moving in the opposite direction. So, it will be 2 plus 1, which is 3 meter per second. So, their subsequent distance between A and B decreases at the rate of 3 meter per second, which is 4, option 4. Next is 114. A particle starts from the rest from the origin and moves along the x axis. Its position as a function of time is given as x is equals to 6t square minus t cube. Here x is in meters and t is in seconds. The velocity of the particle at the equilibrium position is. So, at equilibrium position, net force on the particle will be 0. If force is 0, that means acceleration of the particle will be 0. So, let us find acceleration first. On differentiating x, you will get velocity which is 12t minus 3t square, and on further differentiating velocity, you will get acceleration which is 12 minus 6t. At equilibrium position, m into a will be 0, that means a will be 0. So, 12 is equals to 6t and t will be 2 second. At t is equals to 2 second, particle will be in its equilibrium position, right. We need to find the velocity at this position, that is at t is equals to 2. So, let us put t is equals to 2 in velocity equation. So, it is 12 into 2 minus 3 into 2 square, which is 24 minus 3 into 4, which is 12 meter per second, and that is option 3. Next is P, Q and R vector are 3 unit vectors represented by the 3 sides of an equilateral triangle such that P dot Q plus Q dot R is equals to 0. Then which of the following is the correct relation between the 3 vectors? Okay. So, we have this equation P dot Q plus Q dot R is equals to 0. That means P dot Q is equals to minus Q dot R. Now, you can say that if angle between P and Q is 60 degree, then angle between Q and R will be 120 degree because of this minus sign. Okay. Now, let us draw one diagram. So, we have let us say this is your P vector, this is Q and the angle is 60 degree. Now, angle between Q and R must be 120 degree. So, let us say this is your R and this angle will be 120 degree. By looking at this triangle, you can see that Q plus R is equals to P. Using triangle law of vector addition, Q plus R is equals to P, which is option 2. Next is 116. The ball rolls up the inclined plane then back down. Which is the correct acceleration time graph? So, we have this ball, its g component will be vertically downward. If this angle is theta, then this angle is also theta, and this component of the acceleration will be g sin theta, and this is g cos theta. So, component along the motion is g sin theta. So, when it is going up, its acceleration will be g sin theta downwards, that is downwards along the incline, and when it is coming down, its acceleration will be again g sin theta. That means the ball is moving with a constant acceleration, that is g sin theta, and since it is pointing downwards along the incline, that means let us say it is negative and take vertically along the incline upward direction as positive. So, correct answer will be option 4, right. So, it is your acceleration time graph. Next is 117. The velocity time graph of a particle is shown in the diagram. Rank in order from most positive to least positive the acceleration at points A, B and C. So, slope of velocity time graph will give you acceleration. So, at point A, the slope is this one, which is negative because theta is obtuse angle. At point B, slope is 0 because this line is parallel to this tangent at B is parallel to time axis, and at C the slope is positive. Why? Because this theta with the time axis of this tangent is acute angle, right. So, slope is positive, that means acceleration is positive, right. So, AC is greater than AB is greater than AA. Why? Because this is negative, this is 0 and this is positive, right, which is option 3. Next is a particle starting from rest and moving along a straight line has acceleration A given as a function of displacement x by the equation A is equals to Bx. A is equals to Bx, where B is a positive constant, the velocity of the particle when it has a displacement d is. Okay. So, A is equals to Bx and A is given in terms of x. So, we can write A as V dV by dx, which is equals to Bx. So, you can say that V dV is equals to Bx dx. Now, integrate this equation to get the value of velocity when its displacement is d, right. It is starting from rest, that means its initial velocity is 0. Let us say at a displacement d its velocity is v, initial displacement 0, final displacement is d. These are the limits. Now, integration of v dv will be v square by 2 and the limits are from 0 to v, and integration of bx is bx square by 2 and the limits are from 0 to d. So, let us put all these limits, you will get v square by 2 is equals to b d square by 2 and v will be under root of b d square, which is under root of b into d, and that is option 1. Next is 119. Vector A has a magnitude of 3 units and vector B has a magnitude of 4 units. If the magnitude of A cross B is 6 units, then the angle between two vectors is A cross B has a magnitude is equals to magnitude of A into magnitude of B into sin theta, right. A cross B magnitude is given as 6, A magnitude is 3 and magnitude of B is 4 into sin theta. So, you can see that sin theta is 6 by 12, which is 1 by 2, and sin theta is 1 by 2 when theta is equals to either 30 degree or 150 degree. So, correct answer is option 4. Next question is 120 question. R vector is the resultant of two vector P vector and Q vector, and R vector makes an angle of 90 degree with P vector and 30 degree with Q vector. Then the ratio of P vector magnitude to Q vector magnitude is. So, let us make a diagram first. This is P vector, this is resultant, and let us say this is Q vector. This angle is given as 30 degree and this angle is 90 degree. So, this is alpha, the angle between resultant and P vector is, let us say, alpha. So, it can be written as 10 alpha is equals to Q sin theta upon P plus Q cos theta. Now, 10 alpha is 90 degree, which is 1 upon 0. That means P plus Q cos theta should be 0. Now, angle between P and Q is 90 plus 30, which is 120 degree. So, you can see that P plus Q cos 120 degree, which is minus 1 by 2 is equals to 0. So, P is equals to Q by 2 and P by Q is 1 by 2, which is option 4. Next is 121. Two vectors A and B of different magnitudes are found to have a resultant of magnitude r. On reversing one of them, the resultant is again found to have the same magnitude r. Then the angle between the vectors A vector and B vector must be. So, we have A vector plus B vector magnitude is equals to A vector minus B vector magnitude. It is given that summation is equals to difference magnitude, right. What is A plus B magnitude? It is under root of A square plus B square plus 2AB cos theta, and what is A minus B? It is under root of A square plus B square minus 2AB cos theta. Take square on the both sides, you will get A square plus B square plus 2AB cos theta is equals to A square plus B square minus 2AB cos theta. So, 4AB cos theta is equals to 0, and 4AB are non-zero, that means cos theta must be 0, and cos theta is 0 when theta is equals to 90 degree. So, this is the angle between A vector and B vector, which is option 1. Next is 122. If A vector is equals to B vector, then which of the following is not correct? A vector is equals to B vector. Two vectors are equal, that means their magnitude is same as well as their direction is same. So, if their magnitude and direction is same, that means their unit vector must be same. So, option 1 is correct, magnitude is same, option 2 is correct, and you can write, because A cap is equals to B cap. So, you can represent B vector as B A cap and A vector as A B cap, because direction is same, right. But you cannot write A vector plus B vector is equals to A cap plus B cap. This is the whole vector, whereas this is the unit vector. So, correct answer is option 4, which is not correct. That means the incorrect statement. Next is 123. The resultant of two forces has a magnitude 1 Newton. One of the forces has a magnitude of root 3 Newton and makes an angle of 30 degree with the resultant, the magnitude of the other forces. So, we have two forces, let us say under root 3 and other one is Q. Now, resultant has a magnitude of 1 Newton and this resultant is making with root 3 an angle of 30 degree, right. So, you can write magnitude resultant as 1 is equals to under root of p square plus q square plus 2pq cos theta, and let us put the value of p as root 3. So, you will get 1 is equals to under root of root 3 square, which is 3, plus q square plus 2 root 3 q cos theta, and one more information is given, that is the angle of resultant with the root 3. That means you can write tan alpha, which is 1 upon root 3 tan 30 degree is equals to q sin theta upon p, which is root 3 plus q cos theta, right. This is equation 1, this is equation 2. You can square these two equations to get the value of q, and after squaring and solving this two equation, the value of q will be 2 Newton, which is option 2. Next is 124. If A cap and B cap are unit vectors and if magnitude of A cap cross B cap is root 3 times A cap dot B cap, then the magnitude of the vector A cap minus B cap is. So, let us solve this equation. So, we have A cap B cap magnitude into sin theta is equals to root 3 A cap B cap into cos theta. This will cancel this term, sin theta upon cos theta will be tan theta, which is root 3. So, theta is 60 degree, right. Now, we have we need to find the magnitude of A cap minus B cap. So, it will be under root of magnitude of A cap square plus magnitude of B cap square minus 2 magnitude of A cap into magnitude of B cap into cos 60 degree, which is 1 by 2. So, this will cancel this. Since A cap and B cap are unit vectors, so magnitude of A cap and B cap will be 1. So, it is 1 plus 1 minus 1, which is under root 1, and the magnitude will be option 2, which is 1. Next is 125th question. The graph drawn with absolute temperature T on x axis and pressure of an ideal gas P on y axis is shown in the figure. As the temperature of the gas increases, the volume will be. So, this is your PT graph, and let us extend the straight line something like this. You can find that the y intercept is negative and slope is positive. Let us say it is plus A, and y intercept of the straight line is minus B. So, P is equals to AT minus B will be your equation for this straight line. Y is equals to mx plus c. Now, we have one more equation, that is PV is equals to nRT, right. So, volume will be nRT divided by P, and instead of P we can write AT minus B. So, you can see that as temperature of the gas increases, denominator will increase and overall volume will decrease, which is option 2. Next is 126. The graph drawn between pressure and volume in Boyle's law experiment is shown in the figure for different masses of same gas at same temperature. Then which of the following statements are correct? Options are correct. So, let us draw one vertical line at this volume axis. So, let us say this volume value is V naught. So, corresponding to this volume V naught, pressure of M1 is let us say P1 and pressure of M2 is let us say P2, and you can see that P2 is greater than P1. We also know that PV is equals to M upon capital M RT. So, pressure at constant volume V naught, pressure is directly proportional to M, right. So, if pressure is directly proportional to M and P2 is greater than P1, that means what? M2 is greater than M1, which is option 1. Next is 127. A long, narrow, uniform glass tube is closed at one end and contains a gas trapped by mercury thread of length h. When this tube is held vertical with open end, the length of the gas column is L. When the tube is turned upside down, the length of the gas column is doubled. If the pressure of the atmosphere is 75 centimeter of Hg, then the volume of H in the centimeter will be, right. So, this is your 127th question, right. So, as there is no indication of the change in temperature, so you can apply Boyle's law, which is P1 V1 is equals to P2 V2. So, P1 V1 is equals to P2 V2, and you can write volume as area into height in the column, right. So, it will be let us say 75 plus h centimeter of Hg as pressure, and volume is let us say La. In the second case, length of the column will be doubled. So, it will be 75 minus h is equals to 2 into 2 La, right. So, on solving this equation, you will get the height as 25 centimeter, which is option 2. Next is 128. Two 10-meter long iron rails are separated by 1 centimeter. The value of alpha for iron is 10 power minus 5 per degree Celsius. If the initial temperature is 0 degree Celsius, the temperature at which the rails will touch is. So, let us say temperature at which the rails will touch will be let us say T. Okay. We know that delta L is equals to L alpha delta T, where delta T is change in temperature. Delta L is 1 centimeter, which is 1 upon 100 meter is equals to L 10 meter into alpha is 10 power minus 5, and delta T will be T minus 0. So, T in this case will be 100 into 10 minus 4, which is 100 degree Celsius, and that is option 2. Let us discuss 129 question. It is said that original centigrade thermometer designed by Celsius had upper fixed point as 0 degree Celsius and lower fixed point as 100 degree. Now, this temperature scale we label as Tughlaq scale, and the temperature in this scale as represented by degree T. A temperature of 50 degree T is equivalent to x degree Celsius, then what is the value of x, right. So, let us apply the standard formula for conversion. So, let us apply this formula for Tughlaq scale as well as for degree Celsius scale, right. Lower fixed point for Tughlaq is 100, whereas upper fixed point is 0 degree, but for degree Celsius lower fixed point is 0 and upper fixed point is 100. So, for Tughlaq it will be 50 minus lower fixed point 100 is equals to upper fixed point minus lower fixed point is equals to, for degree Celsius it will be x minus 0 divided by 100. So, you can see that minus 50 is equals to minus x and x is equals to 50. So, correct answer will be option 2. Next is 130. Coefficient of linear expansion of brass and steel rods are alpha 1 and alpha 2. Lengths of brass and steel rods are L1 and L2 respectively if L2 minus L1 is maintained same at all temperatures. Which of the following relations holds good? That means L2 minus L1 is constant. That means the expansion of brass rod is equals to expansion in steel rod. So, let us equate this expansion. Delta L1 is equals to delta L2. So, for delta L1, let us write it for brass. So, it will be L1 alpha 1 delta T, and for L2 delta L2 it is for steel. So, it will be L2 alpha 2 delta T. Delta T will cancel each other. So, we have L1 alpha 1 is equals to L2 alpha 2, which is option 4. Now, let us discuss question number 131. It is given that a horizontal narrow glass tube of 100 centimeter length at both ends contains a gas divided into equal parts by a mercury pallet 10 centimeter long with the system at 127 degree Celsius. Now, one side is heated at 227 degree Celsius while the other side is cooled to 27 degree Celsius. The distance moved by the mercury pallet in centimeter is nearly. Now, initial number of moles in this question will be equal to final number of moles, right. So, let us say at the hot end the distance moved by the mercury pallet is x centimeter, right. So, what you can do is you can equate the number of moles initially and finally. Let us say for hot end the length of the column is now 45 plus x, and for cold end it will be 45 minus x, right, and apply PV is equals to nRT and equate the number of moles initial and final. You will get your answer as 11.2, which is option 1. Next one is 132. Two metal rods A and B have lengths L1 and L2 and same radius. The coefficient of linear expansion of the materials of A and B are alpha 2 and alpha 1 and alpha 2 respectively. Okay. If the two rods are joined to form a longer rod of length L1 plus L2, the equivalent coefficient of linear expansion of the composite rod will be. So, we are joining these two rods, right. So, total expansion of this complete composite rod will be, let us say delta L, which is equal to expansion in A plus expansion in B, and its equivalent coefficient of linear expansion is, let us say, alpha. So, you can see that delta LA plus delta LB is equals to delta L. Now, delta LA will be alpha 1 L1 delta T plus delta LB will be alpha 2 L2 delta T, and delta L is for composite rod. So, it is alpha L1 plus L2 into delta T, right. So, alpha will be alpha 1 L1 plus alpha 2 L2 divided by L1 plus L2, which is option 1, right. Now, let us discuss 133. Water at 4 degree Celsius is filled to the brim of 2 beakers of glass of negligible coefficient of expansion. A boy performed an experiment of heating beaker A and cooling the beaker B. The observation he makes will be, so water has maximum density at 4 degrees Celsius. Its density is maximum. So, if density is maximum, volume will be minimum, right, volume will be minimum. When water is cooled down from 4 degree to 3 to 1 and so on, its volume will increase, right, its volume will increase. And when water is heated from 4 degree to 5, 6, 7, its volume will increase, right. So, in both the cases, volume of the water will increase, and because of that, water overflows in both A and B, which is option 2. Next is 134. A clock has a long pendulum made of brass. Due to a temperature change of 20 degrees Celsius, the time period of oscillation of the pendulum is found to change by 0.02%. The coefficient of linear expansion of the brass is. So, we have delta T as 20 degrees Celsius and delta T is change in temperature, where capital delta T divided by capital T is fractional change in time period, which is equals to 0.02 divided by 100, and it is given by half delta L upon L, okay, half delta L upon L. So, it is 2 into 10 power minus 4 is equals to 1 by 2, and delta L is nothing but alpha L delta T divided by L. Delta T is given as 20, so it will be half alpha 20, which is 10 alpha, and 10 alpha is 2 into 10 power minus 4. So, alpha will be 2 into 10 power minus 5, right. So, alpha will be 2 into 10 power minus 5 degree Celsius inverse, which is option 1. Next is 135. Between 273 Kelvin and 277 Kelvin, the coefficient of cubical expansion of water is. So, 273 Kelvin is equivalent to 0 degree Celsius and 277 Kelvin is equivalent to 4 degrees Celsius. In this case, the coefficient of cubical expansion of water will be negative. Why? Because volume is minimum at 4 degree Celsius, because its density is maximum at 4 degree Celsius. So, water is contracting from 0 to 4 degrees Celsius, that is why volume is decreasing, and because of that the coefficient of linear cubical expansion of water will be negative. Now, let us discuss question number 136. Question is, two identical vessels, each of volume V, contain identical samples of gas, ideal gas. The pressure and temperature in each are P and 2T respectively. Now, they are joined by a very narrow pipe, and one of them is cooled to a temperature T and the other one is heated to a temperature 3T. The common pressure of the system now is. So, in this case you can see that initial number of moles is equals to final number of moles. So, initial moles can be written as N is equals to PV upon RT. So, it will be 2 times, because both of the samples are identical. So, you can directly multiply it with 2, which is P into V divided by R into 2T is equals to final pressure is, let us say, P dash, common pressure. So, it will be for the first container it will be P dash V divided by temperature is T. So, it is RT, and for the second container P dash V divided by temperature is 3. So, it is 3 RT. On solving this equation, you will get your P dash, that is the common pressure of the system, as 3P by 4, which is option 3. Next is 137. A rectangular metal plate has 2 circular holes drilled in it in a symmetric manner as shown in the figure. If the metal plate is uniformly heated, which of the shown distances A, B and C increases? Now, the metal plate is uniformly heated, that means the distances A, B as well as C will increase. Why? Because of the thermal expansion of the metal. So, correct answer is option 2. Next is 138, the temperature corresponding to the midpoint of the fundamental interval in the Fahrenheit scale expressed in Kelvin scale is. So, midpoint of the Fahrenheit scale will be the average of low point as well as high point. Okay, lower fixed point as well as higher fixed point. So, lower fixed point is 32 degree Fahrenheit and higher fixed point is 212 degree Fahrenheit. Its average will be 122 degree Fahrenheit. You can calculate the average by 32 plus 212 divided by 2 and it will be 244 divided by 2, which is 122 degree Fahrenheit, right. Now, we need to express this 122 degree Fahrenheit in Kelvin scale, right. So, it will be 122 minus 32 divided by 180 is equals to K minus 273 divided by 100, and solving this equation you will get the value of K is 323 Kelvin. Next is 139, when a gas in a cylinder is compressed at constant temperature by a piston, the pressure of the gas increases. Consider the following three statements. Statement 1, the rate at which the molecules collide with the piston increases, the average speed of the molecule increases and the molecules collide with each other more often. Now, which of the following statements correctly explain the increase in pressure? So, average speed of the molecule will increase if there is some change in the temperature, right. Molecules collide with each other more often if there is some change in temperature, and because of change in temperature kinetic energy of the molecules will increase, but there is no information about the temperature change. So, B and C are not correct, right. And because we are compressing the piston, so molecules will collide with the piston more oftenly, right. So, correct statement is 1 only, which is option 1A only. Next is 140, if two different gases are at the same temperature, which of the following must also be equal? Now, two gases are at the same temperature, so their pressure is not equal. Average molecular velocities depends on the mass of the gases, and we have two different gases. Pressure also depends on the density and mass, right. Average kinetic energy of their molecules, yes, average kinetic energy of their molecules will be equal because it is given by 3 by 2 kBT, right. So, if temperature is equal, their average kinetic energy will be equal, which is option 3. Next is 141. A particle moving along a straight line covers a distance of 16 meter in the first 2 seconds and 8 meter in the same direction in the next 2 seconds. The distance travelled by the particle in the next 2 seconds will be. So, it is given that particle is starting its journey and in the initial 2 seconds it is covering 16 meter. In the next 2 seconds it is covering 8 meter. We need to find the distance covered by the particle in next 2 seconds. Now, see, it is given in the question that it is a distance, not displacement, right, and we can use this equation S is equals to ut plus half at square and v square is equals to u square plus 2as if we want to find displacement, right. And you can see that the distance covered by the particle in consecutive time intervals of 2 seconds is decreasing, that means it is a retarding motion, right. So, let us find the point where the velocity of the particle will be 0. Let us understand, understand this question, right. Initial velocity is let us say A and its acceleration, initial velocity is let us say u naught and its acceleration is A. So, for the first 2 seconds, you can write S is equals to ut plus half at square. So, it is u naught into t plus half A t square, which is 2 into 2. So, we have 2a plus 2 u naught is equals to 16. So, you can write u naught plus a is equals to 8. Now, for the first 4 seconds, total distance covered by the particle is 16 plus 8, which is 24. So, you can apply this equation for the 4-second time interval, which is 24 is equals to 4 u naught plus half a into 4 into 4. So, it will be 8 4 and 24, you can take the 4 common. So, it will be u naught plus 2a is equals to 6, right. We have equation 1, we have equation 2, subtract equation 1 from equation 2, you will get your a as minus 2 meter per second square. Put this value in equation 1, u naught will be 10 meter per second, right. So, time at which the velocity of the particle will become 0 will be u naught by a, which is 5 second. So, this is 4 second, in the next 1 second its velocity will be 0 and after that it will change its direction of motion. So, distance covered will be this plus this in 1 second, right. Now, see, for this also, this is 1 second in forward direction and this is 1 second in backward direction. So, 1 second in backward direction, initial velocity is 0, acceleration will be now 2 meter per second square because it is moving in the direction, its velocity will be in the direction of acceleration, right. So, for this backward journey, let us find the distance covered by the particle in 1 second. So, it is ut, which is 0 into 1 plus half a into t square. So, distance covered in the backward journey in 1 second is 1 meter. So, distance covered in this forward journey in 1 second will also be 1 meter. So, total distance covered by this particle will be 1 plus 1, which is 2 meter, and that is option 3. Next is 142. A particle moves along x axis with a uniform acceleration. The displacement of and velocity are connected by the equation v is equals to 2 root x, where x is the displacement in meter and v is the velocity in meter per second. The acceleration of the particle is, so v is the function of x. So, we can write acceleration as v dv by dx and it is 2 root x into differentiation of 2 root x. So, it is 2, differentiation of root x will be 1 by 2 into 1 upon root x, right. So, you can see that all of these quantities are cancelling each other. So, acceleration will be 2 meter per second square, which is option 1, right. Next is 143. Consider the following statements. Choose the appropriate choice from the 4 choices given below the statements. Option statement A is displacement of an object is independent of the frame of reference. Yes, displacement is nothing but the change in position of the particle, that is the difference between final and initial position, and it is independent of the frame of reference. So, this one is true. Next is, if a body moves along a straight line, the distance and displacement are equal, right. Distance is a scalar quantity, displacement is a vector quantity. You cannot compare a scalar quantity with a vector quantity. So, statement B is false, right. So, correct answer is option 2, A is true but B is false. Next question is 144. Consider the following statements. Choose the appropriate choice from the 4 choices given below the statement. Statement A, a body moving with a constant velocity is also moving with a constant speed. Yes, that is true. If velocity is constant, that means its magnitude and direction both are constant. Magnitude of the velocity is, by looking at the magnitude of the velocity, you can find the speed, right. So, yes, if velocity is constant, speed will be constant. That means this option is correct. Next is statement B. A body moving with a constant speed need not be moving with a constant velocity. Yes, if its speed is constant, that means magnitude is constant, but velocity is with direction also, right. So, by looking at the speed, you cannot tell about the direction. So, statement B is also true, right. So, correct answer is option 3, both A and B are true. Next is 145. 3 temperatures are given, A is equals to 10 degree Fahrenheit, B is equals to minus 10 degree Celsius and C is equals to 10 Kelvin. Which of the following is current ascending order of this temperature? So, let us convert 10 degree Fahrenheit into degree Celsius. So, it will be 10 minus 32 is equal upon 180 is equals to C upon 100, right. So, you will find C as minus 22 into 100 divided by 180 degree Celsius. let us convert this 10 Kelvin into degree Celsius, right. So, it will be K minus 273 is equals to C, which is temperature in degree Celsius of 10 Kelvin. So, it will be 10 minus 273 is equals to C. So, C will be minus 263 degrees Celsius. Now, you can see that both of these values are negative, right. So, A will be, it is nearly minus 12 degrees Celsius. This is minus 263 degrees Celsius and B is 10 degrees Celsius, right. So, you can see that B is more and least one is C. So, correct answer will be option 2, C is less than A is less than B. 146 question. A sample of an ideal gas is heated so that its volume as well as pressure are doubled. The percent increase in its absolute temperature must be. So, we know that PV is equals to nRT. Number of moles should be constant. So, PV upon RT, this entire quantity should be constant. Now, if you are doubling the pressure as well as volume, that means the numerator will increase by 4. It will become 4 PV. In order to cancel this 4, temperature should increase 4 times, right. Then and then only the PV upon RT term will be constant, right. So, initial temperature is T, final temperature is 40. What is the percentage increase? Final temperature minus initial temperature divided by initial temperature into 100, which is 300%, and that is option 2. Next is 147. An ideal gas has pressure P at absolute temperature T. Its pressure is increased by delta P due to an increase in temperature delta T. If the volume of the gas remains constant, the fractional change in pressure per unit rise in temperature is proportional to. So, we have for the first condition PV is equals to nRT. For the second condition P plus P delta P V is equals to nRT plus delta T, right. So, when you will also you can see that delta P V is equals to nR delta T by subtracting equation 2 with equation 1, right. Now, let us divide this equation 3 by equation 1, you will get delta P upon P is equals to delta T upon T, because volume is constant, right. Now, you can see that delta P upon P divided by delta T is equals to 1 upon T, right. So, this complete term is proportional to 1 upon T, which is option 3. Next is 148. According to the kinetic theory of gases, the temperature of a gas is measure of average velocities of the molecules, linear momenta of its molecules, kinetic energy of its molecules and angular momenta of its molecules. So, according to the theory, kinetic theory of gases, the absolute temperature of a gas is measure of its average kinetic energy of its molecules, which is option 3. Next is 149. Examine the two statements A and B and choose the correct option from those given below. Statement A is, for a given gas at constant pressure, the density is directly proportional to its absolute temperature. So, we have pressure constant V is equals to m upon m into RT, right. So, over here P upon RT is equals to m upon capital M into V. Mass upon volume will be density and it is directly proportional to pressure and it is inversely proportional to its absolute temperature, right. So, if pressure is constant, density is directly proportional to its temperature? No, it is inversely proportional to temperature, right. So, statement 1 is false. Let us see statement B. For a given gas at constant temperature, the density is inversely proportional to its pressure. If temperature is constant, then density will be directly proportional to its pressure. So, statement B is also false. So, correct answer is option 4, both A and B are false, right. Next question is 150. For 1 mole of an ideal gas, the temperature of the gas expressed in centigrade scale is plotted on the x axis and the product PV is plotted on the y axis. The graph is, so we have PV is equals to nRT, but this T should be in Kelvin. But in this question, the temperature is expressed in centigrade scale, right. So, we know that K minus 273 is equals to C. So, K will be C plus 273, right. Now, see, so equation will be PV is equals to nR C plus 273, right. So, PV will be nR C, which is temperature, plus nR into 273. So, you can write this equation as y is equals to mx plus c, and you can see that this is a straight line, but it is not passing through origin. It has some y intercept nR 273 and it has some slope nR. So, it is a straight line and it is not passing through origin, which is option 1.